Yo, what's up, Internet? Since Media here. So today I'm just going to do a quick introduction to this, which is the Protoplug VST plugin. And I'm going to tell you a little bit about this. I hope this is going to be a short video, but it's going to be part of a longer series where we really drill down into this. So what is Lua Protoplug VST? Well, Lua is a programming language, and one of the advantages of Lua as a programming language is that it's designed for embedding in other applications, for writing scripts inside them. So because of that, it has a virtual machine which is very small and light and reasonably fast. So it's not as kind of big as JavaScript or Python, but it's that kind of a language. You'll see it's got some slightly different syntax, but it's that generation, that object-oriented scripting language type thing. And it was designed to be used inside other applications. So somebody took that language and they put it inside this VST. They literally got the code for writing your own VSTs. It uses Juce, which is a commonly used framework for writing VSTs, and they put the Lua virtual machine inside a VST, which is why it's here running inside FL Studio. You can see it's running as an ordinary plugin here. And so what does this plugin do? Well, this plugin does whatever we want it to do. We write the code in this window and it will do it. So this is brilliant. This is absolutely the best geek VST you've never heard of, right? I can't believe more people don't know anything about it or haven't heard of this. It is fantastic. But of course, we're going to have to learn to program it to see what it can do. So today we're just going to have a look at very first simple program that I didn't write. It comes with it. And I'm going to explain how it works, what it does. And then we're going to go on in further videos in this series to explore some of the things we can make with it. So the first thing to look at in this, when you load this up, it comes with a bunch of standard scripts. So you got, this is like any other programming editor. I'm assuming if you're going to watch this series, you've done a little bit of programming before, or if you haven't and you're sufficiently inspired, then you'll go and learn a bit of programming elsewhere. You don't need to have used Protoplug before, you don't need to have used Lua before, and you don't need to have done a lot of program to follow these, I hope. So let's get started. I will put a link in the description to where you download this. It just works the same way that any other VST works. There's nothing complicated about it. So I'll put a link to the site and you can install it the way you install your normal VSTs. And let's go. Let's open this. This sine mouse demo, I think, is a really good way to understand what we're talking about here. I've just loaded it up. You can see the code. You can see that the code is not actually very long at all. And what does it do? Well, firstly, you see there's this button here, compile. Compile just means it's not pink. It's like a lightish red. I've never seen that before. Okay, so that button just compiles it. In other words, it takes this script and it transforms it into the kind of bytecode which is needed to run the program on this Lua virtual machine. So that basically is how you run the program. So we compile it like this, and now you'll notice these three tabs up here. The code tab is the code. That's how you always look at the source code. This params tab, if you've got some standard input controls, they're controlled by these sliders here. But this particular example, the sine mouse doesn't use it. But it does have a GUI. So the GUI is the graphical interface. And here is the graphical interface. So what we've got here is a space with a frequency and an amplitude. And we now just get our mouse and we just do this. So as you move the mouse to the right on the frequency goes up, the pitch goes up. It's playing a sine wave. As you move vertically, the amplitude goes up. So now, what's interesting about this is being synthesized by this code in real time, as is everything else. Now, this is standard VST, so look, let's just demonstrate that to begin with. Let's just put this through some effects. Let's put it through a distortion and put it through an echo. Let's go back to it. I mean, that's cool itself as a thing to play around with an instrument. Let's take the amplitude right down there. Or maybe I'll just change it, recompile it, it'll stop for a second. So that's what we've got. So that's fun, and this is the code that does it. So let's just start to investigate this code. So just to begin with, I want to prove to you that the code is really what's doing all this. So that's green. Let's just find where we can change the color of what it's drawing there. And the color is this line here, G set color, color green, j.color.green. Let's make that red for a second. No, don't do that. I don't want to change that bit. I just recompile like this. Is just how we run it again, and you will see that's now turned red. Right? That is really live code, or not live coding, but that is really, this code is producing that interface. So there are two parts of this code, and now the thing to understand about this is that this is a VST, and it's going to follow the standards that VSTs follow. Now VSTs are normally written in C++ or a language that can do kind of low-level stuff, which makes it all a bit fiddly. And VST is a standard. In other words, when you write a plugin, you have to write a set of functions or a set of components in your thing which interact with the VST, the DAW that is calling it. In other words, the DAW is going to be in charge, right? FL Studio is in charge. FL Studio is making calls into my code, and my code has got to respond to it. So the standard is defined by VST. That was defined by Steinberg for use with Cubase, I think, back in the late 90s, if I remember correctly. And the Steinberg, what's called the Steinberg SDK, the developer's kit, something you can download. You have to do a bit of bureaucracy for it. You've got to kind of make an account with Steinberg and stuff like that. But it's a little bit complicated. Now, this is based on something called Juce, and you'll notice here this variable j equals Juce. What is Juce? Juce is somebody who's created a framework that's a slightly higher level framework. It's a more it simplifies writing VSTs. A lot of people use the Juce framework. In fact, let me just show you here. In fact, while we're here, I'll go to the Protoplug site as well. So I'm going to put this link in the description. This is the place you get this plugin from OSAR. I think the guy's Canadian. Great thing. More people need to know about this. Juce is quite widely known. A lot of people who write VST plugins are writing with Juce, and Juce is, and they have they're pretty good at supporting it, but it's a C++ framework, and it defines a certain way that you write your VST plugins. Now, this Protoplug is built with Juce. In other words, although you're writing in Lua, they've kind of wrapped the Juce C++ API, the application programming interface, in this. So you're writing Lua that calls the same methods or functions as Juce uses. So if you start playing with this Protoplug, not only is it a convenient way for you to start writing your own VST or your own code to live inside your DAW, but you are actually learning a little bit about Juce as well, or at least how Juce kind of represents these things, so that if you move on to then wanting to write your own VSTs more seriously, then you'll already know a little bit about how Juce works. So let's have a look at how Juce works and how this works. The important thing here is this method or function called process block. So almost all audio software works like this. If you're synthesizing sound, okay, you are generating sample points in real time. So if we're working at a frequency of 44.1 kilohertz, in other words, we're generating those numbers 44,100 times a second, which is a lot. Most audio software does not write, say, a function that generates one of those points individually, and then you get, you call that function 44,000 times a second. Almost all of them typically work like this. There is a buffer or a block in your code, and if you look up here in your options, the audio settings, you'll probably see, I think here my ASIO actually defines the buffer length, right? So the buffer length here is defined as 512 points. So the buffer is a kind of array of numbers, and very typically your code receives an array of that size, and every time we call your function to generate the sound, we fill that entire buffer. So we've set the buffer size to being 512. That means we don't call our function here in this code to generate our sine wave one point at a time. We call it in blocks of 512 sample points. So that is what this function here, you can see, is being sent. Okay, there is an object called the plugin. So Lua is an object-oriented programming language, and we have objects and we have methods that belong to those objects. So we didn't have to define that. The framework of the Lua, of the Protoplug, defined that for us. But we have to write the function that is going to do our synthesis. That function is defined here in this block I'm highlighting. We're basically creating a new method or function here called process block, and it's going to be a method of the object, which is plugin. And plugin is the object that represents the whole thing, our plugin, right? This is Juce standard. When you write a Juce plugin in VST, even in C++, you will have to provide a method called process block, which takes these two arguments. Samples is the pointer to the array, effectively. It's the array that you are going to fill with your data, and Smax is the length. So you're receiving here Smax, which tells you how long the buffer is as well. So what do? Well, we're generating a sine wave, and very typically, we've got some data here that represents frequency, which is the frequency of the wave we're going to play, and amp, which is the amplitude of the wave we're going to play. They start by default at 440 hertz and 0, and we have a local, and they'll be reset to this every time we recompile this script. We have a delta. So delta is a very typical word to mean the difference, in other words, how much forward we're going, and the phase. So the phase, very often when we talk about generating a sine wave, we think of the phase as being the position along the wave that we are. So we're starting at 0, which is the beginning, and the delta means every time we advance by 1 point, we are going forward by 0.06. Okay, so inside this block, process block function, we have a simple loop that goes from I equals 0 to Smax. In other words, we're counting through every point within this array of sample points, which is the buffer we've been given. Again, the syntax of Lua is not the same as the syntax of C or other languages you know, but it's very, very similar. You can see what this does. It's a for loop. The I is, for a variable called I, is starting at the value 0. It's going up to the value Smax. And inside that loop, we say do. Okay. Inside this loop, we define another local variable called S, which is going to hold the actual. But if you remember some of my byte-beat code that was in JavaScript, we tended to use S to mean the sample point. And here we just used a math library, math object, and the sine function that's in the math library. and it's a sine of the phase. In other words, the phase being, it's our time effectively. If you remember the byte beats example, we use this variable t. Here we use a variable phase because we're kind of thinking of this as something that's scanning through a wave. So the sine of the phase, and then we just take that value and we multiply it by amp. Right, our amp is 0 currently, so that's going to be what controls the volume. If you remember here, that's going to be derived from where we put the mouse here. So having generated that sample point, we now just put it into this buffer. And what you'll notice is the buffer, as we might have imagined, it's a stereo buffer. So it's got a left and a right channel, or a 0 and a 1 channel. So this is a two-dimensional array. The 0 just means the left channel. So this is the first dimension. The second dimension here is the I that's counting through it. And we just put equals S. We just put the value into there. And we put the value into the right channel as well. These two hyphens here are the way Lua represents comments. So it's just telling us this is the left and right. You can see it's slightly grayer there in this color scheme. Up the top there, you can see there's comments like that as well. So all we're doing is we're generating sine wave points, and we are putting it into both the left and the right channels. And then, of course, we just have to, as we're stepping through the array, we also want to step through the phase itself. So we just increment the phase by the delta. Again, any audio generating code you write is going to do more or less the same thing. The byte beat example we did, you saw something very similar, even though it was in a different language, and we were generating a very different kind of sound. The only thing that's kind of new here that you haven't seen if you saw my previous videos on that is the use of a sine function, but a sine function is like the classic. So sine wave is the classic pure audio wave, and you've probably seen, you know what a sine wave is. So that's it. So literally we just have to attach to the plugin a process block function. There has to be a process block function, because what's going to happen is every time FL Studio wants this VST to generate sound, it's going to say, here's the buffer, go and fill it up with data, because I've got to play that now. And then the next, very quickly afterwards, it's going to say, here's another 512 points, fill that up as well. And so that's what we're going to do. So that's it. There has to be a process block. That's what the VST handles. This code then is all just to define this GUI and how we actually interact with it. So let's look at that. Well, you'll see some more variables defined here. Just as we received the plugin predefined for us as the name that represents the plugin itself, so the name Juce is given to us as the name of the Juce library. The guy who wrote this has obviously decided to just rename that capital J to make it shorter, less typing, or perhaps easier to read for him. So then he creates the variable called frame, and you can see we're actually generating that frame that's coming from this Juce library using this method called rectangle int, which is presumably defining a rectangle in terms of integers. We're saying start at 2020, it's 400 wide, it's 300 high. If you see here, that looks pretty much like a rectangle that's 400 wide and 300 high. So that frame is this graphical element. We're also defining a variable called sideways, and I'm presuming at this point the thing is going to help us rotate this name here, this text here. That's what I'm inferring from this sideways here. After all, it's rotated math.pi times 0.5, which is a 90-degree rotation, I think. Probably. Don't trust me on that until we see it. Right, now we're going to have a function we're going to define called GUI.paint. GUI, again, is being given to us as an object, which is clearly going to be this GUI here. And that paint object is given a G, which is the graphic context. In many languages would call it something like GC for graphic context, or they might call it canvas, but it's a typical thing again. you write a paint function here, and the paint function is being given the thing it's going to draw on and with. So we have to call this fill all. I'm guessing that just sets the canvas to the background color. Then we set the color for drawing. We tested this out before, the J color red, but we can make it blue again just to confirm what's really going on here. Yeah, that works. Now we say draw the rectangle, the frame. Again, that's pretty straightforward. Now we draw some text, frequency, which you can see being drawn down here. These are just the coordinates we're drawing it at, I think. Maybe there's some other information there. J justification center. Okay, so maybe we're kind of drawing it within this box, and it's centering it within the box. We add the sideways transform, so now we're basically kind of rotating our context 90 degrees, and then we're just drawing the text here. So this is what happens every time we paint the screen, and that's happening at a certain frequency. I don't know how often that's happening, but it's something that, again, as part of the VST standard, the Juce standard, the GUI object is going to be called, the paint method of the GUI object is going to be called with this graphic context, and at that point we do our drawing of what we want to draw. Okay, now that's pretty much it for the output of the GUI. Now we just have to see, well, how does it actually handle the mouse? Well, we have a mouse handler function, and that takes an event, and this is very typical in much GUI programming. Notice here that these functions we defined, we were actually defining new methods on existing objects that the Protoplug was giving us. Okay, the plugin represents a Juce plugin. We're given that, and we're just adding to it the process block method. Here again, the GUI object we're being given, and we just add the paint method. Here though, we're defining a new function that's local to our own script called the mouse handler. It's receiving as an argument the object event. The event obviously is going to contain the details of where the mouse is, information like what was clicked, whether the mouse button was down, where it is, that stuff. We have this method here, so this test here, if not frame contains, now if you remember, frame is this rectangle, so frame is this rectangle here, and that seems to have a method called contains. Now, here is something to notice that can catch you out once you start programming in Lua. This contains is a method of the object frame. Frame itself was a rectangle, but it seems to have some methods, one of which is contained, which is going to test if the pointer is inside it. What is worth noting here, and this is a Lua thing, is that we use a colon to separate frame and contains. Lua has a distinction between the object dot something and the object colon something, and I'll explain that in another video, but it's something to notice because you can often find yourself with some slightly subtle bugs if you use the wrong connector here. So the right way to call a method on this function, so the call a method on this object, is to use this colon and not to use a dot. And I've had bugs where I've spent an hour trying to figure out what the hell was wrong, and it's been literally I had object dot method name rather than object colon method name. So that's a gotcha to watch out for if you're going to work with Lua. And I will explain in another video exactly the difference in what they mean. So if not the frame contains j dot point event x. So here we are creating a point object. We're giving it the event x and the event y, which obviously that's where the mouse currently is. Clearly contains is a method that rectangles know that given a point, they can see if the point is inside them or not. So if it's not inside it, then we just return. In other words, the mouse handler, it's going to ignore any mouse events when the mouse is over here and outside that rectangle, right? So that's just testing that it's really inside the rectangle and then just bailing out if it's not. If we did have a mouse event, like a mouse click, and we are inside the rectangle, then we get to this point and we say freak equals, now freak, remember, is our global variable that represents the frequency. Started off at 440, but it's now going to be changed. Equals event x plus 80. In other words, it's getting its value from the horizontal position of this cursor. So if I click further to the right, then the value of that event x is going to be higher, and so therefore the value of frequency or freak is going to be higher. Again, that's what we'd expect, right? The further to the right you click, the higher the frequency of the sine wave gets. Similarly, the amp is 320 minus the event y over 300. So again, the further up we click here, the higher the amplitude, the further down, the lower the amplitude. Again, when you think about it, it sort of has to be like these. These are slightly magic numbers, like the 320 and the 80 and 300. These are just how we get from the coordinate system of our window here to the appropriate values of the numbers for our sound. Right, having now set our value of our frequency or amplitude, what are we going to do with that? Well, local SR equals is the sample rate known. So if the sample rate is known, and that's something the plugin clearly knows how to give you, and now we're going to get the sample rate from the plugin, right? And that's what's the value. So this is a kind of conditional expression. Basically, we're saying, look, if the sample rate, we know what the sample rate is, the plugin knows what it is, get it, and assign that value to SR. On the other hand, if we don't know it, we're going to default to 44 kilohertz or 44.1, which is standard. It's a default audio standard because that's the way CDs work. I think that's where it comes from. So we've now got the sample rate. So now we're now going to update the value of delta. Now, if you remember, delta is this value that's used to scan, to increment the phase. In other words, that's the speed that we scan through the sine wave. And of course, the faster we scan through the sine wave and take our points off it, the higher a frequency audio wave we're generating. So we've now generated SR, the value of SR, and we're now updating the value of delta to be a function of 2 times math.pi times the frequency, and the frequency is the position of our mouse, and divided by the sample rate. In other words, that's the calculation that finds how do we need to change this delta so that the frequency that we scan and generate this sine wave is the frequency that we want to give it according to this horizontal position here. Again, once you see this, that should all be pretty obvious why it has to do that. So there's 3 parts. There's the process block, which is the bit that actually generates the sound wave based on some of these numbers. There's the painting GUI thing that just draws what's on the screen, the view of our interface, and the mouse handler, which does the calculation of when we've clicked on the GUI, recalculate the new amplitude and frequency. The final thing we just have to do here is we have to add 2 handlers to the GUI object to say, for the mouse drag event and for the mouse down event, both of these cases we're going to attach this local function called mouse handler to it. It doesn't matter whether we're clicking for the first time or dragging either of those 2 events, we want to update these values of frequency, which is why we can now So if you can see what or imagine what I was doing there, in one of those cases I was dragging and getting that continuous tone, and in the other case I was just clicking randomly around and getting the mouse down event. So that is a very simple example, but I think it's a very informative example of how you use Protoplug to write your own VSTs. Okay? you just install the Lua Protoplug VST itself, open up this. There are some other examples here, and we will look at those in future videos, and we will write some of our own. Again, there is nothing, once you look at it, you go through it step by step. Everything here is absolutely the way you would imagine it should be. It has to work like this. There has to be a bit that generates our sine wave. There has to be a bit which paints the screen, and there has to be a bit that handles the mouse input. And that's all you need to generate something which actually can be put into, inside the context of your DAW, something you can actually play with. So again, this is part of our DAW world, so we can just set our simplest beat going and we can jam with this. Take all those effects off for a second. Suppose we think that we've kind of decided that really we'd like to go higher. If you look at this again, that's not really the highest we would like it to go. Let's change the code so that we can actually get to some higher frequencies. So instead of saying frequency equals event x plus 80, I'm going to say event x times 2 plus 80, which is going to give us a wider range of things. Actually, I want it even higher than that. Let's make it times 4. And this is going to let us go to a much higher frequency. So you can see we have the control. We can now decide, well, we can now start taking this code and making it do anything we want. And I'm going to do several of these videos, so if you're interested in this, subscribe and keep watching, because this is really good. I mean, I am quite shocked that I just don't see more people talking about this, because I think it's a fantastic plugin. You can really do exciting things with it, and it's hard to write VSTs. And I mean, I'm just starting to sort of learn how to do it. I have been working with Juce and doing it all in C++, and it's quite a lot of work to do that. So it's great to have something like this, both to learn and to do it as an easy way to get into this, both as a way to sort of, it's called Protoplug for obvious reasons, right? It's for prototyping your plugin ideas. So you can write something here to get a feel for it, and maybe later on you think, well, that's because, of course, just to be clear, C++, when you compile it, is a fast language. You could make a powerful plugin that does a lot of work and a lot of calculation in C++. Lua is a language which, when you compile this, it compiles to a bytecode that runs on a virtual machine. That obviously adds an overhead. You couldn't, I don't think, write some huge synthesizer that really needed to do a lot of calculations in this, because it would be a little bit too slow. It's probably 100 times slower than doing it in C, doing it in this. But for simple, a couple of oscillators, ideas, and you can use this not just to generate as generators. You can also write audio processing plugins as well. So we will see a few of those, few effects in future videos. So you can, for doing basic prototyping of ideas, for making simple plugins that are going to help your, to make the music you really want to make, this is great. And it's much, much easier than really getting to grips with and writing C++. It's not conceptually that makes C++ so much harder. Generally, it's all the extra tooling and infrastructure you kind of need. You try and compile something and it doesn't compile because some library isn't right or whatever. Here all that's kind of done for you. The guy that did this has already put all of the hard work of getting a VST working, and he's just put this language, the Lua language, inside it, so it's done for you. So that's it. That's all I'm talking about today. And just to say, if you're interested, this is going to be a series. I'm going to go a lot deeper into this. We're going to develop some more scripts for this plugin. It's free software, open source. Go get it. You don't have to pay anything. Start playing. And yeah, I'll see you in the next one. Thanks for watching.